All right. Well, okay. This talk is about weaponizing serialization flaws in Perl using MetaSploit. Um, really, I spent a huge amount of time weaponizing Perl serialization flaws in MetaSploit. Spent not so much time actually putting together a talk on it. So it's going to be rough. Plus, like, I'm going to try to take you through the entire process of how the things were found, and then how they work, and then how you actually write the code to attack them. And that is a huge amount of technical material. So all along the way, I'm going to skip lots and lots of details and just point you at the important bits. If you get lost, don't really worry too much about it. If you really want to dig into how something worked, I'd be happy to go into more specifics afterwards. So starting off really basic, what is serialization? And show of hands, who could give me a nice definition for serialization? Yeah. Okay, well, if the term sounds a little alien, just a real simple example, you load up data dumper, you take a data structure, you print it out through dumper, it gives you a string of what that data structure looks like, right? And deserialization would be the exact opposite. I take a string that a dumper gave me, put it into eval, and then I get that data structure back, and I can dig into it, right? And I think everybody hits this really early on when they're learning Perl, that you can save complex data structures this way. It's not a really terrific way of doing it, though, and so sooner or later you learn about purpose-built serializers. In Perl, obviously we can do the dumper eval trick. In most other languages, they'll have something equivalent, but they'll be language specific. Perl also has storable. It's had it for a very long time. Instead of printing out Perl code, it prints out a binary format. Serial does the same thing. It's a serializer written by the folks at Booking.com. They always promote it very heavily at YAPSEs. You want something that's language agnostic. The old go-to was XML. And now XML is not quite as popular as it once was. YAML was popular for a little while. Now it's not so popular. And JSON's always there. And of course, other languages are going to have their own binary serializers. Like a common one you see in Python is pickle. They also have Marshall. PHP, in the core, they have serialize and deserialize built in. So pretty much all PHP code is going to lean on that one. And so since you have so many options, it really gets into what sort of features do the serializers have. And you ask yourself questions like, to handle all the different data types that are important to me. We're Perl programmers, so to us, the difference between an int and a Boolean and a string is kind of unimportant. Other languages, that's very important. How efficient is it, both in terms of how rapidly it can move data through the serialization and deserialization, and how compact is the data once it's serialized. Because frequently you're serializing data and then inserting it into a database. You don't want to just waste tons of space. Does it handle objects that are embedded in my complex data structures? Will it handle a code ref or a callback that I have embedded in that data structure? And kind of one thing that people don't think about very often, but if I have a very big complex data structure where parts of it are repeated, can I actually put that repeated part in its own separate serialized object and then reference it from one to the other? To plot out all those serializers I talked about before, as far as data type support, that's pretty universal. Although you could look at the Perl specific ones, and they're not going to map very well into other languages because Perl just doesn't really have those data types. Speed, the purpose-built ones are generally pretty good, except for XML, which is just kind of a ponderous format. Is it human editable? A Perl programmer would probably tell you that dumper output is human editable. Most people would disagree. But I have heard before that dumper is a nice format for hand editing. XML, a Java programmer would probably tell you that is a great format for hand editing. They can write it, on a sheet of paper. Normal humans probably could not. Some of the other ones, though, like YAML and JSON, were specifically designed to be easy to edit, although they're still a little complicated. Object support is one of the features that you see in a lot of them. Like XML doesn't really natively support objects. A lot of people wrap some sort of object support around XML, but the format itself isn't designed to handle it. JSON doesn't support it. The others all do. Coderef's very uncommon. And external data, that's mainly something that you see in XML. I listed Pickle and Thumper as supporting external data simply because they run code. If you run code, you can load external data. So here, though, we're talking about attacks against serialization formats, and that leads into safe formats versus unsafe formats. Personally, I hate those terms safe and unsafe. They imply there's this black and white, division between them, and it just never works that way in reality. In our particular context, we're talking about web application and a web browser, and some sort of serialized data moving back and forth between them. And in that case, there's like a clear division there, right? The browser is something that you don't trust, and the web server itself is something you do trust. So as soon as you round trip that data through the browser, it becomes untrusted. When it's untrusted, a lot of these features are actually very bad things. Obviously, when I deserialize it, it executes code, that's super duper evil. So I definitely can't use Pickle or Dumper, If it supports external data, that's a very nasty trait because basically I can use your Etsy password file as my external data. In fact, there's a name for that type of attack because it's a very specific feature of XML. It's called an external XML entity attack. Objects are also a really nasty thing to do. It seems like objects should be safe, but the reality is a serializer doesn't know how your objects were created. It doesn't know all the constraints that would go into your objects. When it serializes an object, it takes all the settings from that object and just spits them out, right? And then when it recreates the object, it doesn't go into your constructor. Instead, it just puts all those settings back together and says, you are that object. And the nasty thing this allows, it allows the serialized data to muck around with the guts of the object, things that normally code shouldn't be able to touch. And then once you've mucked around with the guts, you can do all sorts of nasty things that the objects naturally do.
Well, and some of them support like.
Yeah, some of the serializers, if you build your class so that it has special methods to tell it how to reproduce the object, then it can go through that. But generally speaking, almost all the serializers, they will work in the absence of those methods, which leads us into our problems. We're going to get more into that in a second. But after scratching out all the ones that aren't really safe by default, that really leaves us with very limited options. Essentially, JSON's the only one that default settings is very safe to use. You can make the others safe. Like I can turn off the external data in XML processing, but by default, it'll have it. Serial, I can turn off its support for objects, but by default, unless I take affirmative action, it's going to do objects for me. For this talk, we're going to go and talk about storable. Storables, first it does the standard object thing, which most of the serializers do objects. And as I mentioned, to attack that, you just put a bunch of evilness in the middle of the object, and then you do things that objects are going to do without you actually trying to get them to do. So most common is that I go ahead and I create the object, and I wait for the destructor to get called when that object goes out of scope, right? But beyond that, you can also hook into wherever it's overloaded. So if that object, when you use it as a string, does some special thing, I can hook data in so that when it does that, it does something evil. You can also, some objects, like in Perl, they have auto load, where they magically create methods for you on demand, and some of them you can hook into that as well. Storable actually goes a little bit beyond that, though. Let me switch over. Oops. I want to show you real quick. So here we're going to jump into Storable. Storable has like a thin Perl wrapper, but most of its guts are in XS code. And there's one really interesting feature of Storable that's very different from the normal I create object serializer. If we follow this down. Okay. So this function here, Storable is reading across the data that's handed into it, a bunch of binary data. It sees a special marker that says this is an object coming after it, right? But it doesn't just have one type of object that it supports multiple types of objects. One is this hooked object, and what that is saying is that when I serialized this, I saw that this class had a special method, storable thaw, attached to it. Storable, as it tries to process all this stuff, first it puts together whatever was inside the object. And then eventually it gets down here and it says, okay, now I got my object together, and I'll go ahead and I'll bless it into that class, right? And now I'm going to ask that object, can you thaw yourself? Because I know you're supposed to be able to thaw yourself. And if it says, nope, I can't do it, Storable says, okay, well, must be the module's not loaded. So then it comes down here, and it loads the module for me. And then it asks it again, can you thaw yourself? And if it can't, it does a croak right here. Croak is not like a normal Perl croak. It's in the C code. It actually aborts the execution of the process instantaneously. Like Perl doesn't really shut down when it hits this. So it's kind of special. Oops. Why did I do that? Okay. One other interesting trait of this, right? This load module in XS, this is basically equivalent to a require, right? Not a use. So what happens here is that whatever goes into that, it doesn't have to be an actual class name. It can be a path also. And it will gladly append .pm to it and load that path. It has to end in .pm, and basically the whole system is going to a horrible death if it didn't find a storable thaw in the class name, which if it's a path, it's never going to be in the class name because it's just not a part of the class. One other interesting thing, storable. So another object type it can have is an overloaded object. So when Storable was freezing this object, it saw that it had overloading on it. So stringify, nummify, add, code ref, one of those was overloaded. And with an overloaded object, it's going to do the same thing. It will come in, pass it into that class, say, do I see that there's overloading attached to it? If not, go ahead and try to load the module and then see if I have overloading on it. Okay. So, recap. In Storable, I can load any path that has .pm in it, right? Anywhere on the file system. It will die immediately afterwards, but I can load it. I can also load any module that on the system that has overloading if it's anywhere in ink. And then I can load any module that has a storable thaw method in it. That is very unusual behavior for the serializers. And that's one of the reasons, like, I have a toolkit of just basic greppers that I run over any new Perl code base that I see, and storable is one of the very prominent things I look for. Because if it's a web app and it's moving storable around, very frequently it's being done wrong. So let's get into the actual web app we're looking at today. And that is MovableType. Has anybody ever actually worked with MovableType? Anyone? Yeah. Okay. Well, like the design of MovableType is pretty straightforward, right? Like MovableType is a collection of CGI scripts The way that it works, you put your content into the CGI scripts, you hit the publish button, and then it generates a bunch of static web pages, right? And those static web pages have links that lead back into the CGI scripts themselves, right? So I go to add a comment to a blog post, it feeds me into the CGI scripts. And let's take a look at the CGI scripts. So, like, this is just a old install. You extract one directory, then you go visit it the first time. It has you configure it. It's pretty common setup for web applications. These, although they're named CGI, there's one that is not, in fact, a CGI script. It's mtconfig. That's the config file that has what database it's connecting to and what the database password is, yada, yada. The CGI scripts themselves are kind of interesting. They're very bare bones, right? All they're doing is setting up the library path and then immediately going into MT app and then the same name as the CGI script itself. Let me load one of those. And then this, you can see its base class is MT app. We go to MT app. And we can see its base class is MT. And then this is sort of our global object that everything loads and really the guts of how dispatching, authentication, translations, all that kind of hooks into this point. If we go back, though, to one of these, what basically happens when you go to a page in the CGI scripts, it calls the init and does a bunch of setups. And then it does init request is really where it feeds into, and you actually get into that function of the CGI script. There are only a few CGI scripts, so in init request, it'll kind of fork off into different parts of functionality that each one accomplishes. So the main thing we're talking about today is storable. Here, like the namespaces here, the extlib, these are a bunch of embedded CPAN modules. You can kind of ignore them. Just imagine it's getting them from these libmt. These are all the actual MovableType modules. You can see they actually put all the storable stuff in a nice namespace, libmt serialized. And this is kind of confusing, but it has multiple types of serializers. The default is MT. Let's go to that one. This is, in fact, not a deserializer. It's a dispatch table for other deserializers. Basically, their serialized data has this marker at the front, STRG, and it has one number that is either 0 or not 0 for first serializer or deserializer they implemented. It pulls another off and then dispatches it to the empty number. You can see their first one was right here. It's a bunch of unpacks. The second one is macro wave, which was all that garbage we just went through. And then thaw MT3 goes into storable. Right. Thaw MT4 is JSON. Why they have so many different serializers and why it auto which one to use, couldn't explain it. But it's what it does. So basically, if we want to get to storable thaw, then we got to feed in, STRG, then a 0, then a 3, and then we feed in our storable data. That's where we land, right? And frequently when I audit stuff, I start off with where do I want to land, and then I trace backwards to how do I get to that point. I think it's serialized. PHP lib. Okay. Yeah. So, like I mentioned before, all of the CGI script map into a module, MT app, and then CGI script name, right? So we can see right here from the namespaces, we've got MT app wizard is doing some deserialization, right? MT app upgrader is doing some deserialization. These other ones are happening in the guts. and they could be data from the database or something like that. This upgrader script, on most installs, they say to delete it, that you don't want it actually available to anybody. When you do visit it, it blocks you out pretty thoroughly. MT App Wizard is a little quirky, like, let's go to where it serializes. Unserialized config. Okay, an unserialized config goes into unserialized, which is where the data ends up. And right above that, you can see this is hex packing or hex unpacking the data. So it'll be fed in as a hex string. It turns it back into the storable data plus the header, and then it feeds it into the unserialized right here. And if we go all the way back, right, one step, it does it right here. Oh wait, I didn't show you the other. Okay, one other thing. This app param is essentially a CGI param. So this is config being read from the browser right here. Okay, and run step right off the bat, it's going to do that. And if we go to init request, we can call it at the very end. We get into run step, and right in front of that, here's the magic block, right? This basically is saying, okay, if I have mtconfig.cgi, that means movable type is already configured. The wizard is designed to configure a movable type, right? You should not enter the configuration wizard if it's already configured. Makes total sense. Except, oddly enough, if you send that your step is the seed step, or that the mode that it's running in is a retry mode, it doesn't seem to care that the configuration file already exists. Oddly enough, this won't allow you to save the config file, but it'll allow you to run every single step in between the very first step and the very last step of saving it. So all the middle steps, you can actually enter into them, although most of them abort somewhere in the middle because they'll figure out sooner or later the configuration file exists. Let me show you just real quick. Let's move the empty config out of the way. And if I go back here,
There's your missing config.
yeah, that one is not redirecting, right? Okay, but this one redirecting, right? So I go in here and I'm thinking, I speak English. You know, I have all the modules. I want to use MySQL. Oops, and then give it the database and yada yada. So basically, the exploit that I came up with, and this was in fact the second serialization flaw I found in MovableType. There was an earlier one with comments and a parameter that was kind of left over where they were deserializing that one. And what happened when I reported that one to them, right, is that 6 apart, they have kind of a cycle like cPanel where they only do security releases every few months, right? And given that I work for a cPanel security team, I'm on both sides of that. I don't really like the long wait, but at the same time, I understand, the realities of how things work. The odd thing is the first time I reported that they had a storable flaw, then they put out a fixed version, right? And if you read through their fix, they make absolutely no mention of the fact that they had the serialization flaw. And I contacted them afterwards, and I'm like, look, I explained to you that was a code execution bug. And they're like, oh, we couldn't reproduce it, and so we just fixed it. Didn't document it anywhere, we just fixed it. And in fact, they only fixed it in one of the 3 versions they were supporting. So I'm like, you should have asked 2 months ago. Here's a payload, and I'll request the CVE for you. Kind of moved on. Fast forward a year, and I'm reading OSSSec and find out that they had an SQL injection. I'm like, okay, well, that's interesting. I know what their code base looks like. I want to see how that works. Download the latest version, look at the changes they made, look at how the SQL injection works, run my greppers one more time, and it's like, wow, okay, so they have the exact same serialization flaw in the wizard. I would have figured they would have fixed that when they fixed the first one. So I wrote to them, and this time I'm like, okay, they kind of didn't get it last time, so I'll make it very clear. And then payload, how to reproduce it, and then send them a blurb saying, hey, look, I'm giving you a local file inclusion payload. Local file inclusion payload is not really all that bad for most people. But that's not the only type of attack you can do against this. It's very clear that you can do remote code execution through this type of an attack. And I bet you can guess what they put in their changelog. It says, yeah, it's a local file inclusion. So, and without debating it or anything like that, I kind of get it. To be honest, if they had been ambiguous about the impact of it, I would ignore it. The fact, though, that I said specifically it's not local file inclusion, that is just one example of what you can do. And they put it out there in their announcement that is exactly what it does. Kind of, tweaked me a little bit. So I decided to prove definitively I could get remote code execution off of that flaw. Let me show you, though, the local file inclusion really quick. Okay, and we'll go empty wizard. Oops. Okay, so here I'm just getting an error message. It's saying it can't load that module, right? If I actually put temp local file inclusion.pm in place, it would run it. And let me show you what the payload looks like for that. Back to okay. So basically, to create a payload that does that, I'm creating a package that is a valid package name. It has to be a valid package name, otherwise Storable is going to freak out when it tries to serialize it. And I don't want to figure out how to write Storable by hand, so I want Storable to do it for me. I tell it that the package has freeze and thaw method, so it's going to go into that load module. Then I add magical MovableType serializer headers. The data, the strings in Storable are not encoded, gzip, any of that stuff. They're just left as strings, so I can manipulate them directly. And I'm changing the X's to double dots and the underscores to slashes. So I get a class name that has a path traversal attack in it, right? Pretty straightforward. And when it loads, it tries to load that module just like it had required it.
I assume you're getting to this. How do you get that file on the server?
Well, see, that's why local file inclusion attacks aren't all that important. Okay. Like for HostGator and cPanel, local file inclusion attack is devastating, right? Because we deal with shared servers all the time. Most people don't deal with shared servers. They deal with individual servers that are serving one website. And in that case, you would have to find some other way to upload a file named .pm somewhere and figure out exactly where it is so that you can do the local file inclusion, which is a much higher bar to cross over. But like I said, local file inclusion is not all we can do here. So the most obvious attack, like I mentioned, against object deserialization is destructors, right? So where I started off on this was looking at all the destructors that ship with MovableType, right? Every last one of them. And originally I was very, very narrowly looking at HTTP cookies because it would write out files when it closed itself. I couldn't find any way to get that one to load though. Eventually I kind of settled on extlib DPI. And if we look at the destructors here, this one's doing some Windows stuff. This one closes a file handle. Not really helpful. Does nothing. And this one, okay, so it's going to take itself and then dereference it into a string, and then it unlinks it, right? That's pretty useful. And this is CGI temp file, right? And like I mentioned, MovableType is one of those web apps that sort of auto-configures itself, the first person that logs into it. So I got a really nice attack point here. Basically, if I can remove the configuration file, then I can reconfigure it and do whatever I want with it. So let's switch over and look at the payload for it. Okay, so now we're looking at an actual MetaSploit module that will attack that particular thing. The MetaSploit modules are written in Ruby. You know, I'm not a Ruby programmer, so I did a lot of copy and paste to put this together. Up here at the top, you've got all sorts of metadata about the attack, information about it. We've got some constraints on the payloads, like how much space do I have for the payload, what characters does it have to avoid using in the payloads. MetaSploit will automatically build payloads that'll work into whatever constraint you give it. And I can add options here. I'd say, okay, I need to know where the CGI bin directory is that all the MovableType CGI scripts are installed at. And then the exploit itself, okay, this actually has three different parts. Right? Part one is we're going to delete the empty config CGI using the storable infection, right? And here we go into empty wizard, we bypass, we're at a middle step instead of the beginning or the end steps, and then we got our injection. Let me show you how I got that injection.
Config parameter you're talking about is your injection?
Yeah. That's hex encoded. What is this? Okay. Sorry, I can type on occasion. Yeah, it's hex encoded storable data with the special header so that MovableType treats it as storable data. Same thing. And this one's pretty simple. I need the package. I create, this is a file I want to unlink, and then I got to bless a reference to that scalar into the package. Then I just freeze it in. And now when MovableType serializes this, it will create that object, bless it into that class. The class is already loaded. And then when it hits the destructor, it'll unlink that file for me. So that's the magic number right here. Then after I've unlinked it, go back and skip to the last step and go ahead and reconfigure it. In this case, I'm sending enough parameters to get it to the point where it tries to initialize the database. And there is no way to specify the exact module that it uses to connect to the database. But there are other configuration directives that will specify the exact module. So what I did here is the email address, I just some garbage, then I skip to the next line in the empty config, a new line, and then I enter in, and this is the database driver I want you to use. And I want MySQL and then a bunch of raw code after it. Where this ends up is a string eval to load that module. So basically I can do my injection here. And this injection is pretty straightforward. I'm going to print out content type headers. And I'm going to look for the XYZZY parameter. If it's there, I run that through system. And then finally, I'm going to unlink the empty config so that whoever comes to this machine next won't be able to see whatever I just did. And then I'll exit so that it stops cleanly. And then the final step here, we actually send the payload. So we go to empty config, we send the XYZZY with the payload that MetaSploit has given me. And all along the way, I'm checking the status, printing out little status messages. And that's it.
When you're done, then it will be unconfigured.
Yes, it will be unconfigured.
Use the local file inclusion vulnerability to read the config so you could replace it?
It wouldn't run. It has to run. Like I can run code there, but if it, like I guess you might get a syntax error early on in the MT config, like on the first line. But the way they structure it, it's a good point. I should actually try that. Actually you can't, because it has to end in .pm. And because that load module is in C code, I can't put a null byte in it. It's actually a C string when it goes in at that point. Yeah, believe me, I played around a lot with trying to get the local file inclusion to work a little better, but it's kind of limited with what you can do with it. Oddly enough, the very first time I found that injection to storable, it was a root exploit on cPanel.
Oh, nice.
Yeah. And we fixed that a long time back, but.
How do you now?
Don't install it.
Yeah. No, we all make. Let's run this damn thing. My dev console. I'm like not going to get crazy with explaining how MetaSploit works. To be honest, I have a very, very sketchy knowledge of exactly what all MetaSploit does and how you use it. I'm not a pen tester. I'm a developer. And a lot of the features they have in it are about like doing company-wide audits of networks and systems and whatnot. And they're lost on me, The cool thing though is that it gives you a lot of tools so that I don't have to figure out how to write the payloads. In fact, I can throw 20 different payloads that MetaSploit has prepackaged for me. And once I get access to the machine, MetaSploit, and my understanding is it has modules that will try to do post-exploitation attacks. So once it gets on the machine, it can try to improve its privileges and whatnot. But to actually do this thing, so we're going to exploit Unix, web app, MovableType, and we want destructive. And if I hit info, it tells me about this module. That's all the stuff that was up at the top. Right here it's saying the options and which are required and which are not required. Some of the required ones have defaults. Here, though, I need to rhost, and that's the IP address of my test VM. And URI is actually CGI and MP. And then I just hit exploit, and, it does the magic. And at this point, it doesn't give me a proper shell because, in fact, we're in the middle of a system call. But I'm connected,
Oh my gosh.
Oh yeah. Yeah. So
If you do that, then you could find that config file and take it their database. Well, no, you can't.
Problem is,
already destroyed it.
yeah, I already destroyed the config file.
Etsy password.
The terminal's
Look,
messed up. I can show the current one though with injection because it shouldn't. I don't like it. That makes sense. Oh, okay. So I guess like the system is actually running, like the system is sort of daemonizing itself, and then it went ahead and unlinked it. Yeah. But yeah. So okay, there's one way to do.
But you're only going to be the user that Apache or whatever their website is set up as. So you only have that privilege.
Yeah.
You wouldn't be able to say, do anything destructive that Apache couldn't do.
Unless MetaSploit has a way to escalate privileges.
Yeah, and they're like it has some tools to escalate privileges. We like the security team at cPanel, we were trying to learn about MetaSploit, and we did one session where we were using it against the OWASP broken web apps, and we managed to root the thing in 2 hours. Like once we got a shell on the machine through one of the web apps, then we just Googled for kernel exploits. If they haven't updated the machine in a while, realistically, it's very hard to keep a machine secure from local attack. Like shared hosting, they actually focus on this because if they don't keep it secure, it's going to be really nasty. Most people with websites that are one-off things, they're the only people that access. They don't actually keep them all that secure from local attack. So generally speaking, you can actually break out. Even if you couldn't, it may be sitting at the border of the network, you know, where it actually can act as a bridge to go further in. So I mean, there's definitely a lot you can do with it once you get that kind of access. Let me show you though. So yeah, like we were talking about though.
So what if you WCAT the entire site mirror and then upload it back and then lose all functionality of movable type, but you can make the website look the same?
But
Yeah.
capture people's passwords.
Oh yeah,
Phishing attacks,
yeah, definitely so. Like you were pointed out though, the problem here is I lost the empty config in the process, right? I had to unlink it to get the attack to work, and that's really suboptimal. Plus, this whole attack, this has nothing to do with storable. Every one of them that does objects would do this exact same attack. If they had used YAML, I could do this exact same attack.
There's no reason they couldn't have just dropped all the other serialization formats, right?
What do you mean? And just
Why didn't
use?
they just use JSON and be done with it?
I think for backward compatibility, because this is also the serializer that does their database. So, like, you may have data in the database stored in one of the other formats.
Upgrade your database.
Huh?
Upgrade your database.
No, it's not the database itself. It's just that you store a blob into the database. When you reload it, you deserialize it, and you get the data structure back.
You know how this works. Yeah, okay, we can update that. Now we can update this.
Yeah.
We can update that. We'll get to it someday.
It can definitely be kind of a complicated thing to solve. Let me show you there. So I definitely was not satisfied with that as my attack, and because it is destructive and it's obvious that you just attacked it. But so I wanted to focus really on the features that Storable is really weird about, right? I can load any module on the system that has overloading or a storable thaw method, right? Storable thaw method is very uncommon. Overloading is very common, right? In fact, I came up with this little test mod. So if I load a module, then I can say, okay, did this module have overloading in the outer namespace, the one that I can actually load directly? If so, then I can load that module. I can load every module that was loaded by this module, right? And then I walk through every namespace, including the embedded namespaces, and say, you know, do you have a destroy in that namespace? Do you have overloading on that namespace? I probably should have done, do you have auto load in that namespace also, because that's another thing you could target. And then that gave me this hunk of mess after installing every Perl module that Debian provides on my system here. So we can see like PDL matrix. PDL matrix does have overloading. All these modules are loaded by PDL matrix. These namespaces have constructors. Once you load all those modules, yada yada. And then that leads into a list of the ones that are actually attackable. Okay, so here's all the loadable. Keep going. And then these are all the ones with overloading. And then these are all the destructors. So basically that gives me a huge list. And this is just the Perl modules that Debian ships. If I start going to CPAN and pulling down all those, so I can enumerate every possible combination of destructors, overloading, and auto-loading, it gets crazy.
Why is this significant?
Because it doesn't matter that you have MovableType installed. It matters what Perl modules are installed anywhere in your ink paths, right? So the fact that you have MovableType is just one part of it. But I'm not restricted to MovableType. Every Perl module you have installed on that system is something I can attack by loading it up.
So you could program really good and defensive, but still be exploitable.
Yeah, because you have random module from CPAN installed on your system, and I can load that one and attack that one. So I don't have to attack movable types of modules.
As long as you have a local file inclusion?
No. This is because when Storable sees a module with overloading or a storable thaw method, it loads the module for you. That's the thing that we're targeting, is the fact that it loads modules that are not even loaded. That is a weird behavior for a deserializer.
So it's the fact that my app is using Storable.
Yeah. That's ultimately what it comes down to. And I spent a hell of a lot of time going through this list until my eyes were bleeding and whatnot. The ones I kind of ended up focusing in on were first Try Tiny. Try Tiny does not have overloading. It does not have a storable thaw, but it is a very common dependency. It's very easy to load this one through some other module. And
You never mentioned endblocks.
what it's doing, it's normally package scope though.
Well, but if you can load, well,
Because I can't inject the package. I can only inject an object that's blessed in the
but if
package.
it loads the code and there's something funky in the required block that works on it.
That's possible. Actually, I know from searching CPAN, like there is at least one module on CPAN that sets the storable code ref loading to true globally. I don't know how you'd load that one. I don't know if it has some feature that you could load that one. Plus, it's got to be obscure because that's a really dumb way to do it. The fun thing in TryTiny is this actual sub-package, the TryTiny scope card. So what this is, it creates an object, and once it goes out of scope, it runs some code. First thing on the array is the code that it's going to run, and then you got the code, right? And normally I love these kinds of things because I work at cPanel and we don't have a lot of code that has use strict. The problem is once you have use strict on, what TryTiny does up here, put a string in where it's expecting code, it says that you can't run a string as a reference. That doesn't directly work. But on the other one, what was it?
Put a string there for this package name. But it doesn't. You don't have a subroutine there to report on.
Right. It's like I can't put a string in there at all because it wants a bear word there so that it so object. What is that other one? Let me see. Sorry. Object. Okay, yeah, this is the other one that I ended up focusing on. This one, okay, so check out right here. Here's our overloading, and it's got a huge overload table, right? And it has the juiciest one right here, which is this is a code ref, right? So it's pretty uncommon that you overload. I wanted a code ref, but this one does it. Yeah, and we go into the overloading of get code, and it's always going to return a sub because it creates an anonymous sub right here. So it'll always be a code ref. And then inside is where it's actually running the thing that it thought was the function you wanted to run, which is based on an embedded sub object down here. It gets confusing. The thing with this, like, it has strict, but it's only strict bar, right? Not strict ref. So that thing that it's treating as a code ref doesn't actually have to be a ref. It can be a string. Yeah. So, all right. Real confusing, but let's press on. Heed back to.
So, like, why wouldn't they just use strict like everything?
Be intentional. Like they want you to be able to put a string in it.
Be able to use symbolic references.
Yeah.
So
That's not an here's the thing, like it's very easy to look at all along the way and think, why didn't the middle step prevent that somehow? Like I inserted a new line into their config file through a parameter, right? Like you might say, why did it not reject the new line? The thing is, that interface is for an admin, and it really shouldn't have to protect against that. The fact that I got to that point, was really the problem.
Yeah. So copy everything on this file.
2003.
Yeah. Okay. So here's what my actual payload for this damn thing is going to look like. This one's definitely more complicated. Let's skip down here. This is the data that I'm going to serialize itself, right? First, I need to load the TryTiny module. And to load the TryTiny module, I actually create a datetime object. which has overloading and is pretty common. Then I need my try-tiny executor object, which is going to be a try-tiny scope card with a multi-type object. Multi-type object is the first one. That's my code ref. And then these are my arguments to it, right? And there's my object multi-type, which is going to turn into a code ref, and it needs that multi-type saver. The multi-type saver, basically, this is the code that I want to run. MP run app, right? You put them all together, and basically, try-tiny scope card is going to execute MP run app with this as its argument. And so this is my payload. You can like guess it goes into another string of L, right? And basically the injection here, I'm running system, and you can see there's nothing actually here, and then I pad it with comment characters out to 1025. That's because I'm actually going to insert the payload directly into this thing. I'm going to shuffle the bytes around slightly, and whatever MetaSploit gives me as a payload, I'll insert it between these braces. And then there's a new line and exit. Okay. Let me run that. Yeah, and that's what it looks like. So to actually do the payload, though, I got to rewind off of the semicolon, closing parenthesis brace, which is going to be that right there. And then I insert my payload in front of that. And then I'm going to reinsert this padding of the comment characters minus the size of the payload, because storable stores the size of how big the strings are. And then I got this garbage at the end that came after the string. Let me switch over and I'll show you that one. Same sort of thing, a bunch of boilerplate at the top. Okay, and then here's our payload. That's all the stuff that was at the beginning. Then we put in the payload and we turn it into hex, right? Then we have the closing brace, closing parenthesis, semicolon. Then we insert comment characters to pad it out the rest of the way. And then all the stuff that was after it. All right, so we're injecting the payload directly here in one step.
In MetaSploit, you can limit the size of the payload.
Yeah, it's up at the top. I have it restricted to 1024, which is plenty, because all it really needs to do is start some sort of reverse shell. And generally that doesn't take that many characters, especially when we're already in the middle of the system call. Let me make sure my movable type is actually correct. Okay. Okay, that's good. Okay, now movable types back to working. Let's do MetaSploit. Sorry, SF console. Yeah, I think a long time ago it was actually written in Perl, and then they switched it over to Ruby because Ruby was the new hotness. Yeah.
I don't quite understand rewriting an entire application. So there's a group that's starting to want to really?
All that work.
That's amount of work.
So we got it loaded.
Because somebody has the problems with the code or the language, and not the people who wrote the bad code in the first place.
Okay, so this one in the info I got, it's down at the bottom. It says specifically this payload is using object multi-type and date time. It would only work if the system has both those modules installed. If you wanted to get real fancy, you could spend the next 2 years going through all the modules on CPAN and enumerating all the combinations that would get you remote code execution. To be honest, doing one was plenty for me. You know, I'll leave it to somebody else to figure out the next one. So we got to set our host, we got to set the URI, and we hit exploit, and then we're there. And that's it. Yeah. So And now we have the empty config. Whoops. Nah, I just typed it wrong. Yeah, there's
You don't get
This isn't going over port 80. This is a reverse shell that was set up.
I didn't actually configure the payload. I just left it as the default. I honestly don't know how this one works. But there's some of them where it'll open a port on the server. There's some of them where it'll connect back. I don't know what the default payload is, to be honest. But yeah. So that's pretty much
So
all.
what's the ID here?
Huh?
If you run ID.
Oh, www data. Yeah. I don't know if it is a shell. I would expect not. No.
But can you run?
Yeah, but you could say /bin/.
Oh, it does have a shell. So yeah, I can also drop a .ssh key in here and connect up that way. So that's actually when we were doing OWASP broken web apps. Like we used this interface to get in there, but then we immediately created a SSH key and used a regular shell because the lack of up arrow and whatnot was killing me. But yeah, that's pretty much all I got.
Well, I mean, that's amazing what I've seen.
Huh?
What was the name of that module?
Which one are we talking about? The object multi-type?
Object multi.
Yeah.
So you're saying MetaSploit is the one that does the actual heavy lifting of the shell stuff. You just give it the payload and it actually puts its or shell or whatever it is.
The key thing about MetaSploit, right? MetaSploit is a toolkit and a framework, right? So like a lot of the stuff, like how do I encode this? How do I encode that? What types of payloads should I be sending? How do I do a reverse shell? I don't have to know all that. I just have to know how do I get a remote code execution bug, and then I wire up that portion, and then I get to use all of MetaSploit stuff for the rest of it. It actually, like from what I can tell, MetaSploit tends to focus more on Windows vulnerabilities that are like actual buffer overflows and things like that. It has a whole lot of tools for that. I don't tend to focus most of my efforts in that sort of direction, just because I spent my entire career programming Perl. But I think a lot of its tools are actually focused on that. Like there's a tool where you can basically, if you can get a code injection, it hooks up this whole framework on the server side where it can like drive all sorts of other things through it. It seems like the shell tools are not quite as developed as those Windows binary tools are developed.
So it looks like you're running Kali Linux, I guess. Did you find that to be like maybe the easiest way to sort of get spun up on or get a working copy of MetaSploit? Yeah.
Definitely. If you're interested in MetaSploit in particular, definitely get Kali. Because Kali also comes with Zap. It comes with, I think, Community Edition of Burp. It comes with WP Scan.
Okay, well, what was those two before WP Scan? What were the other two programs?
Zap and Burp are web app scanners. So, like they basically fuzz web interfaces.
So they look to see what exploit might work, and then you go back to Metasploit and say, here, shoot this one.
Metasploit is generally packaged attacks, right? Mm-hmm. So, like if you're running the vulnerable version of MovableType, then like the payloads I wrote will work on that, right? You run the other version, it doesn't do a thing. Like either it works or it doesn't work.
But nonetheless, you ship this and suddenly it's trivial for somebody to
attack that version.
Yeah.
And then what's the process like if you publish this sort of module or whatever you might call it for Metasploit, and how do I, I've installed Metasploit now, how do I pull down your particular module?
Presumably they have a repo and you
I run MSF update and I pull down the latest update. Go to I don't have internet, but if I went to exploit DB, they actually track like the latest updates to Metasploit. There's a Git repo where you can send pull requests and whatnot. But the idea, here's the trick. Obviously, creating canned attacks makes the threat more serious, right? But the reality is there's nothing secret about how this attack works, right? It's not like that all of the relevant details are out there. And to be honest, like my main driver in creating this is that these were not the 6-part folks were not the only people I've talked to about storable flaws. I've talked to several CPAN authors and said, you cannot have a module that sends storable to the browser and then takes it back to save data across a request. It simply is not a valid use of the thing. And you get sort of I don't know how the attacks work, so they must not exist. That's always very upsetting because it actually takes only a couple minutes to find one of these flaws. It takes a hell of a long time to prove that it works, and tailoring it to their specific environment. Even worse if it's a CPAN module, because I don't even have an application to go with it. It's just some utility in the middle of an application.
Which that scares me more because I don't know all the different modules I have in there sometimes.
Yeah.
And that your attack surface is beyond my knowledge base.
Yeah.
So what's your next step?
For this, I need to clean it up. I want to actually implement the check methods, and I need to put like how the payloads were generated into the module.
Well, by that I'm asking, are you planning on providing it to the CVE or to MovableType or?
Well, these were fixed months ago, So.
But only in certain versions.
No. They fixed it blanket. It basically after the first one, and I got a CVE for them, they went back and fixed them. And after the second one, they actually fixed the serializer, so by default it just will not do storable, which is a good change. That's really what was needed.
So they did upgrade whatever legacy databases were storing storable blocks.
I think they basically set the default so it doesn't do storable. I think they also provided some conversion tool if you did have that type of data somewhere. But realistically, most people shouldn't have it, unless you've been carrying around MovableType a very long time.
And their default is what?
I think the default is the microwave, which is their custom deal, And I actually didn't read that code. It's too painful.
I have to say I was surprised that you said that serial defaults to objects.
That surprised me too. But if you actually go read the documentation, it defaults to doing objects, that's why
because the whole reason the booking guys created that was to deal with the storable problems, and then they added object support.
These things end up always being used like a dual use of I want to save data to the database and I want to transfer data to the client. I think it's fine if it does objects as long as that's not the default. All of the unsafe things should be things you have to turn on. And it would be even better if I can say you can do objects, but only this type of object and only through the hook that I provide you to do the object. That would be perfect.
Well, presumably if theirs doesn't auto-load, your attack surface is smaller anyways because the only thing you can attack is what they uploaded.
Yeah. But that's generally sufficient. Pretty much if you have a Perl or a PHP application that does unserialized, their equivalent, just the fact that you're doing that is generally considered to be a vulnerability. Which is good because otherwise you've got to spend hours and hours connecting it up with exactly how do I attack it. And if they don't fix it, they say, oh, well, you couldn't actually come up with a payload. Then I just got to wait until some poor developer writes something that actually connects it up. That's a bad thing. Just accept that deserializing it that way is the vulnerability. Whether or not the payload works right now, you're opening up all the innards of your application.
Nonetheless, they're effectively allowing tainted data to be deserialized. Bottom line, that's bad, right?
Kind of, yeah. Well,
Can you talk a little bit about the CVE process?
Okay, sure.
So from like, hey, I think you guys should fix this, and then saying fuck you, and then
It sounds more like they're using the la la la.
oh,
La 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 la.
No, like for me, when I report vulnerabilities to somebody, I try to make it clear that if they don't ask for a CVE, I'm going to ask for one on their behalf, and preferably the person who wrote the software should contact MITRE. They have a special email address to do it. They contact them before they fix it and ask for the number, right? And then MITRE writes them back with a number. They use the number in their changelog, right? Real simple for everybody. Virtually nobody will do that. Only the biggest shops will actually do that. So what ends up happening is I contact somebody, I say, okay, here's all the problems, and then how they fix it goes all over the place, right? Some people will immediately commit a fix, right? Not tell anybody, not say that it's a security issue, not even care whether or not it's a security issue. They would just fix it. In fact, this is why I never send patches when I report a vulnerability, is because it increases that temptation to just patch it and push it to GitHub, without any concern for letting anybody else know that it was vulnerability. So instead, I make it very clear that I think it's a vulnerability. I make it very clear that I'm going to ask for a CVE if they don't ask for one, and then I prod them to ask for it. Generally, they don't ask for it anyway. When they put it out their fix, then I'll go on OSSSec and just ask for a CVE on there, for that software. And generally, Red Hat assigns them there. If the software is in Debian, you can actually contact Debian's security team, and then they'll contact the upstream authors, and they can also assign the CVE numbers. In theory, Oracle could do it too, but they wouldn't.
What does the CVE number do?
It's all it is supposed to be that everybody talking about this vulnerability talks about this one number. It just so there's no ambiguity as to what we're talking about. We're talking about this specific thing. That's the whole point of it. There's people view it as a negative thing though that you have CVEs or even that you fix them. Like it's a marketing sort of thing that Microsoft had 100 of them or something like that. It's not supposed to mean that. And if, to be honest, just software that has no CVEs, all that indicates that not very many people are using it or looking at it. Because all software that's being actively developed will have security flaws. If you see software that has no vulnerabilities reported against it, that makes you wonder why, because surely they're making a mistake somewhere, But I don't know. That's kind of the process I go through. I have a big spiel I send to people when I report something.
Do you have ever concerns that when you're going to contact somebody that they're going to be like, oh, authorized computer access?
I would never test it on their machines. No. I always set it up locally and test it on my own.
Yeah, because that's a violation of the.
Yeah, people
CFA.
going to jail for yeah.
It's bad form, It's real bad form to go and test on other people's machine. The reality is, certainly at CPAN, we'll get lots of reports where it's obvious people have been, scanning and trying to do things on our machines before they tell us what they were trying to do. And, we always tell them not to do that, but it's not going to make any difference. I would rather them tell us about a problem than not tell us about a problem, whether they were doing bad things when they saw it or not. That's just kind of my feeling about it.
Does CPAN exist in this system?
That's a good question.
No.
Exploit. Yeah, that would be fairly.
Forget it. I thought there was one CPAN one in here. Like I said, most of the exploits that are actually in here, they tend to be focused on Windows.
No.
Oh, did we have one at one point?
No. Wait, no.
What's this little guy? It's ASCII art.
Get a random one at a time.
Yeah.
It's not returning anything for CPAN.
Is that a case insensitive search?
think so.
Come on, Jay.
Try harder.
Build something.
Yeah, it looks like it.
All right, so they don't have specific reasons listed.
There's like a paid feed for MetaSploit. I don't know what it adds as far as exploits. The cool thing, like all of mine right now, I didn't give them to the MetaSploit author, but they're sitting in a local directory. So like if I had a huge list of canned attacks, I could just check them in the Git and carry them around locally.
So can you clarify, in your grid where you have like the serializers that work on objects? Well, like JSON, I know can go like from and to blessed, refs. So can you clarify like what object means in that sense? Are you storing the blessed type? Is that the difference? Or?
That it would bless it automatically. Like JSON does not. The specification of JSON is only basic data types: maps, arrays, scalars, integers, boolean.
The JavaScript calls an object is actually a hash.
Right.
Yeah.
So when it says it stores an object, it's just storing a hash.
Right,
No,
but like
you-
I can deserialize JSON into a blessed, but I guess the difference is I have to explicitly
You have to
on the
bless
server.
yeah.
bless.
Right.
All,
But this other
this
type,
global
you
does-
can
doesn't
store the
match
blessed.
What's
it
required?
does. It turns it into an object automatically for you without you asking to turn it into an
So
object.
that's where you can put like date time and actually override their date time. Like
Yeah, the serialized data explicitly has to specify what to bless it as you deserialize it. Otherwise, it's not dangerous.
Well,
And as JD pointed out, while it's doing the unserializing, it can load any Perl module on your system so that it can finish deserializing, which is beyond scary.
Yeah, I'm sitting here looking at this thing and I'm freaking.
I'm just wondering about the origins of this in Perl core. It's got to have been, we'll put this in this helper.
Yeah.
Because the obvious thing is, well, you should load the module that you're going to need if you're going to deserialize it. Otherwise, let it fail.
Quite likely it failed once. I said, I can fix that. Come on. How many
That's a one-liner, right?
Yeah, it's a
Bless.
one-liner. It's fixed.
It's going back to 1994. We can look at the source code and figure it out.
Well, there's like my focus has always been kind of on Perl, not so much on like buffer overflows and C and whatnot. Storable, if you actually go look at the bug tracker, it has lots of crashers in the bug tracker. I would assume you can also just attack it in those ways as well. If I can make a deserializer segfault, that's generally kind of a bad thing.
Have you thought about Tide also?
It doesn't do types. Yeah.
Yeah.
If you read the code, it actually freaks out when you try to serialize the tied object.
So just to back up a little bit what Chris was saying, so does that mean like when I use JSON, I tell it to include blast, and I implement my own to JSON and from JSON, that's bad? I shouldn't be doing that?
Because the JSON
Because I had
format,
to write that.
yeah,
to
the JSON format doesn't automatically load modules or anything like that. So JSON is just dumb data most of the time.
Right, but then you could then come back and bless it, but unless you if you put some sort of a function in there or something.
Yeah, I guess the key point there is you're the one that decides what objects get loaded as opposed to the data, which is tainted.
Now, if you have code that says, look at this hash key, and
And
if you
load
see it
random-
bless the hashes, that would be bad because you're effectively putting in the badness that
On a slightly different version, if you read in a key and call system on it automatically, you can see where this would not be a good thing.
But I can see like having something that is namespace down and being
Yeah.
like, oh, one of the keys is going to be type, and that's going to be, so I have a thing type that extends something.
Yeah, so you basically are going to have to build a validator for each piece of data that you're intending to bless. Otherwise, you're risky.
What you're describing is if you go read the YAML spec in detail, that's exactly what YAML does. There's a special markup in the basic, because the YAML looks almost exactly like JSON, except there are certain keys that say what follows is an object, and in fact it's a Python object in this class, or it's Perl object in this class. That's written directly in the spec there.
Don't forget like the Mongo stuff that uses all JSON that you can pass through. And they have specific, like even in Python, there's a part that it's called, it turns it into code, just the JavaScript, and then arbitrarily runs it.
So MongoDB is what did it, or what?
What was that?
Did you say MongoDB does this?
There's MongoDB drivers, for example.
Oh, drivers.
Like that, when you go to MongoDB, a lot of times to do your mapping, reducing, all those other functions, you have to give it a JavaScript function to do it.
Mm-hmm.
And in Python, you're giving it the data, and you say type is code, and then it executes that on the MongoDB server as the MongoDB itself, which is almost gives you a pretty damn good JavaScript server-side stuff to do. So it's could potentially be dangerous if you allow it.
No, it could be. It sounds dangerous.
Yeah.
I would assume if they added that in, they added it in very intentionally. You know, yeah. Well, the trick is like with like the serializer flaws. Almost always, people didn't intend for the behaviors that it does to be available. You know. Like when somebody very intentionally wants it to do those things, like generally that means they're aware of them, so they factored them into what it's.
They're aware it's a thing to map MongoDB, the JavaScript, into the Python and make it fit. Which is like if you look at the Google Charts data API, it does some weird wonky stuff with it too.
Yeah.
So there's a lot of times that things are manipulated, so to speak, to do that. Everybody's got that little, I'm gonna do some voodoo.
Yeah.
And it's usually the voodoo that voodoo's on you.
I actually remember dealing with almost exactly this problem back in the late 90s on a web server we had written in the place that I worked on. And we had our own little template language. Everybody's got template language, right? And I had explicitly had it where every keyword you put in went through a map to map it to the real code. And somebody went in and took that out and replaced it with the equivalent of an eval. And then I took one of the templates and showed him what I could do with that eval and put my code back. Because it's just, you don't want to give people access to the internals of your code. So with the stuff you were talking about, you could have a type field like that. And if you check the type field that it was one of the keys that you expected, it's cool. It's that it checks to see if it's loaded on disk somewhere. That's the scary part.
Yeah, but it goes back to you have to validate anything that comes in from external sources.
Yep.
Every till has got to be checked.
The guy that tried to make the eval out of it, his thing was, all this code is complicated. I can simplify it by just doing this one thing. And yeah, that simplification took out all the validation.
So he was doing a coded eval?
This wasn't in Perl, this was in a different language, but basically, effectively a string eval. It's like, no, you don't want to do this. Why not? Here. Oh, okay.
Is there a reason why, and this is obviously very naive, they don't fix storable?
Yeah.
When we fixed it in the cPanel, we actually contacted them about that.
This people at Storable, you mean?
Yeah, we contacted the Perl security team, and we sent them patches so that you could turn off the blessing of data, you could turn off all the load modules, and what they wrote back, which is a very reasonable position for them to have, was that fixing those things didn't make any difference, right? That Storable just was not designed for this purpose, and so even though we fixed those, they assumed that you could still execute code through it, even fixing all of the problems we focused on here.
So are they saying if you like keep it server side, then it's safe as long as you don't give
the path you were talking about is you're accepting a storable object through the CGI, and that's how that got onto your system.
The key thing is like there is an unequal relationship between the parties. The person that generated it, the person that's consuming it. The person that's generating it is less privileged than the person that's consuming it. So basically, if the less privileged person can do bad things to the more privileged person, that's where your problem is.
MovableType could have done some extra.
MovableType did.
Like,
they did. You could store. Yeah.
If let's say MovableType was sending me a storable blob that I didn't send back, right? I'm deserializing it on my machine. then that has a potential for them to execute code on my machine, but I'm the less privileged party in this relationship. Or let's say you go run Windows Update, and instead of sending you an XML file of the available updates, it sends you an exe, and you run that. It's like obviously that they could do nasty things, but they're the update system. They could automatically do nasty things. Whereas if it goes in the other direction, like Microsoft wants crash reports and I send them EXEs, that could be very bad. Yeah.
Well, you put the auto run file.
Right. There you go.
But
So the short answer is that my explorable said you shouldn't be using it that way.
what the Perl security team said is that basically these problems are unfixable with this format. That they don't feel like they can make it secure for untrusted data.
And that was the right response, because the bottom line is the best advice is do not use storable if you're crossing privilege boundaries or you don't trust the source of the data.
But I can still use declone.
As long as you are the creator and consumer.
Yeah.
Declone doesn't cross a privilege boundary.
As long as you know you have control over both ends. But yeah, sure, it's no problem.
It's not like there's a flaw in the serializer. It's a flaw in the way that it's a flaw in the things that you can do when you're feeding into the deserializer. The serializer itself doesn't have problems as far as I'm aware. But even if it did, how in the hell did they get into your data structure to begin with? That would sort of begs its own questions how they would have gotten it.
It all starts with an injection point.
Yeah.
If you can find the crack and put something through it, that's what it is.
Yeah. Yeah, when you're rating vulnerabilities, one of the key things they always say is you look at that moment of contact where the vulnerability first starts. That's all you're rating, right? Everything subsequent to that is not really a part of the vulnerability. So for instance, what we showed here, we had basically one code execution, we had one unlink, right? The fact that I turned that unlink into code execution isn't actually a part of that particular payload. Only the unlink was the real injection itself, But we actually, at CCon, we switched over to doing CVSSV2, and that always makes it a little clearer.
What is that you said? CV what?
It's like a scoring system. So when you get a vulnerability, you can go in and you score it. So let's say we did the local file inclusion version. That injection was just local file inclusion. So it's a local, it's a low complexity, it's no authentication, and then partial. Complete would be basically I got root off the thing, right? And then in my version, it's a no authentication, remote code execution. Then that's network accessible, low complexity, no authentication, partial. So we got 7.5 versus 4.6. That's a huge difference. In terms of the score.
So what's bad?
10 is bad?
I was going to say 0.1 is bad.
There's no shades of good, bad. It's all relative, right? So the idea of scoring things is that I want to focus on the things that are most important, right? I only have so much time in the day, and I want to fix the important ones. I kind of like CVSS though, because it has these other metrics. That's like the base score. So let's say that's the unauthenticated remote code execution scoring, right? Then you got temporal metrics. These are things that change over time. So generally they're not added in because over time it'll just change on its own. So let's say I sent them a proof of concept. They sent out an official fix. They confirmed it, right? That's what it was a couple days ago. But now I got a functional exploit. So it bumps up to 6.2.
Yes, the higher number, though, still means a more vulnerable state.
Yeah, higher is worse.
I'm not understanding the point of the base graph over on the top left.
What did you?
So base is the.
So I assume the overall is what we've been discussing, but what's the point of the base impact excludability?
Yeah, exploitability is 10.
See, like the base score is broken into two parts, right? There is how much damage it does, and then there is how easy it is to attack it, right? Something that's trivially easy to attack but has low damage is still very important. Something that has catastrophic damage but is very, very difficult to attack is still very important. So, like, they have it broken up. This is the total score. This is how much of an impact it has. It doesn't have that much of an impact, but it's very easy to exploit it. Right? That's how the numbers are breaking down. And then we get to temporal. These are just factors that change over time. Like as soon as they release the fix, it lowers the temporal score. As soon as I create a MetaSploit module, it raises the temporal score. And then you get into like my particular company. Maybe we are a MovableType hosting company, you know, so all of our machines are MovableType. Or maybe I have never even heard of the thing, you know, so it hits none, and then the score drops down to 0, you know. I just don't have anything that matches this, or somewhere in the middle. And also in the environment, it's like I have some of these machines, but they're not so important. I have some of these machines, they are the core infrastructure of my company. You know, you basically, by plugging in all these variables, you can say how risky this particular thing is versus 20 other things you haven't fixed.
That's interesting.
Yeah.
We were talking about disaster recovery the other day. Are these metrics we use for the same?
They like disaster recovery and security are very closely related because they're both about mitigating risk. You know, you obviously it gets shown over and over again. You cannot stop all attacks, right? But you can lower the risk of them as much as possible, and by setting up your networks correctly, hopefully when somebody does get a toehold, you detect them right away and you limit the damage they can do. That's really what it's all supposed to be focused on.
So this website is nist.gov.
Yeah.
How is the government involved in the CVE process?
I think MITRE actually runs CVE, like they're at the core of it, and I think they're government funded. MBD, they actually do tracking on it. That's my understanding.
So this was so the NSA could outsource
Right.
security exploit.
Not really. Like this is I think like it's one of those things like the IP address assignments, right?
Yeah.
Basically, you do need some government agencies at the core of it, just to keep everybody on the same sheet of music.
But this is effectively international, right?
Well, it's optional too. You don't have to participate. You don't have to ask for CVE numbers.
Does a Russian or a Chinese database exist equivalent to this? Or?
Well, there are other ones, but I'm not aware of any foreign ones being popular. Like a lot of the other ones, the numbers are not as widely accepted as CVE numbers. There's some other things they run also. One is OVAL, which is definitions that you can run against your machine, and it tells you which CVEs you actually are exposed to. And of course, if they plugged in the vulnerability scoring, then you can also see, you know, how big of an impact would this particular vulnerability have. And there's another one, it's called CWE, which is common weaknesses. And that focuses on ways that people tend to misconfigure their systems. Say like Bugzilla. With Bugzilla, if you integrate it with email, your email system must absolutely positively assure that when it accepts an email from an address, that it really came from that address, because it bypasses a lot of their authentication logic when emails get processed in. They have that documented in their documentation. But if you didn't have it configured that way, because you didn't read that documentation, that would not be a bug in Bugzilla. They documented it. You know, that would be a weakness in your configuration.
They turn the email system into an authentication system.
Well, they can't really ask for your password when you send an email. So the thing is, you can do certain control characteristics.
I was going to say, we put that somewhere in the body.
But I don't know. I actually suggested them that that was a bad design. I mean, I wasn't going to argue that it was a vulnerability. You know, they have it documented. It's very clear. You know.
I paid $400.
Drive your car wrong, you know, it's forward, making you a bad car.
Yeah.
It's not their fault you're driving into a wall.
Well, there's a point like the Perl security team did with Storable, you know, where you just cannot fix it. It's the way it's designed, and you have to document it.
So there's actually like a Perl, like how there's Perl porters, there's a Perl security group.
Yeah. It's a weird setup though, because they only do core Perl. They're not even they kind of want to be informed about the dual core stuff, but they're not directly responsible for it.
What do you mean dual core?
Huh?
Storable is dual.
Yeah. But that was also maintained by all the people that were on the core.
Oh, you're talking about who upstream is.
Yeah. It gets kind of weird because as soon as you factor in CPAN, like they have nothing to do with CPAN. There's nobody in charge of CPAN. You get stuck dealing with everybody individually. Some people are real great to work with. A lot of people just aren't. You know, it's like they put a module out there 4 years ago. They don't care that it has a flaw in it. You know, I don't know. I've had a lot of frustration with this.
Do you find that people are resistant, or people just don't reply?
Like the common thing is you contact somebody and they say, okay, I'll fix it, and then you don't hear from them again.
But they're individuals. They're not like companies or something where, you know, it's like if I get around to it, I might do this, you know, but I'm going skiing this weekend, so I'll see you later.
Yeah. I got the module that actually validates all the signatures on the CPAN mirrors. It's called module signature. And I reported 3 flaws to the guy that wrote that, along with example payloads of how to attack them all. And it took him 3 months to fix it, right? Or it may be a she. It was Audrey Tang. So a he or she.
Well, an English speaker is probably a female, but you know.
Okay. Well, I'm sorry. Either way, but
Female transgender this person.
okay. Well, but the key thing is like this the developer is not a bad person. They are not negligent. You know, he responded very quickly when I sent the report, right? And they said we're going to fix it very quickly. And then 3 months later, I'm still sitting on it, right? And I hate doing that because that means I got to remember that I nobody else knows about the thing. So what I do, like when it happens like that, is I contact them again and I'm like, look, I just want to get it out of my tracking. So if you're not going to fix it, I want to open it up in a public bug tracker, and then I'll get CVE numbers assigned, and now it's just an unfixed vulnerability, you know. And that's fine with me, you know. I like if you're not going to fix it, then you know you won't fix it. But that's happened quite a few times. I think there are still some where they're unfixed on CPAN.
I think I'm going to bring that up in Utah and see if I can get any interest to basically have some sort of policies along those lines. Unfortunately, a lot of the pause folks who would be instrumental on this don't go to YAMC.
Yeah.
They come to Open West.
Brian Foy is one of the bigger ones that I'm aware of. Some of the other ones are in Europe.
You know, Debian has the same problem because a lot of packages are owned by individuals and they uploaded it 2 years ago and they really don't care about it. They're not actually using it. That's why it's nice to have a security team that basically has veto power. You know, like when somebody reports a vulnerability and the security team just can't get any action, they will kick the damn thing out of the archive.
So,
you know,
it would be another approach would be to email, I think it's modules at cpan.org, or whatever the mailing list is on this topic.
Yeah.
And just bring up the idea that, okay, well, maybe there needs to be some sort of security veto power.
You could just offer a paid service for secure CPAN modules that are offered and patched, and you just make people subscribe to it. And
I was actually thinking of doing something similar.
And actually just implement that with simply
I mean, it'd be a great business.
But it's, the thing is, though,
vulnerabilities that are,
it's only going to be companies, so they're willing to pay. The individual wouldn't care.
Right, but it's the companies that you want to do. Why do people go with Microsoft for accountability?
Some of them though, it's hard to even view their bug trackers. You know, like some of them are on RT, some of them are in different places.
Right, but what you would do is say, okay, you audit certain versions of stable code for different things of the major usable packages, and then anything else you bring in, you do an audit of that version, and you offer literally it's kind of like a stamp of guarantee that when they hit and pull from your repository, it's got a strict rule set, it's got strict, everything else, and only, it's more like an LTS type thing where you only put things in that are absolutely necessary and audited.
Yeah.
And you build this repository up, and you charge people to be able to hit it and get it. For like companies that say, you know what, CPAN itself, just any arbitrary module, things like that, could potentially be exploitable. I mean, look at most people. What do? Oh, it's missing this one. Install.
Yeah.
And
I'd go, well, see, that's what scared me, because he was attacking, modules that I wouldn't even consider. I know the ones that I know about, but I don't know about the ones I don't know about.
Mm-hmm.
Yeah.
So would you include a module like storable?
I wouldn't use that one.
Apparently, there's nothing.
See, yeah, that's the thing. It's like there is no safe and unsafe. It's all how you use it. Like if you use it in ways where those things aren't bad, then like I would.
If you've got key tree or whatever the command was, it's kind of an indicator they're serializing something, unless they're going out to disk.
Well, I mean, certainly you could grep for some things, but they do that with C code, all the time. It's real common. Like C, oddly enough, is like there's so many great tools to find vulnerabilities in C code. All of the common mistakes, it's like the language still sucks, but there's so many tools that make up for that.
Well, they were trying to figure out if the Heartbleed could have been detected with static analysis.
Yeah.
I don't remember if there was one that could. I mean, it seems like something that you could detect.
There was
There
was a guy just the other day. He posted a paper on how like he could wire up a fuzzer, and he had to do some kind of initialization of the SSL connection, but then he would fuzz after that. And it was like a combination of the fuzzer and address sanitizer, and he could detect it. But most of the people that talked about his paper were saying it's very easy to come up with how you would detect it after you already know it's there.
That's true.
Yeah.
Hindsight's 20/20.
Yeah.
How similar is this sort of work to your day job?
I like with this, I don't worry so much about completeness, like like at the cPanel security team, somebody reports a vulnerability. Once I feel confidence of vulnerability, I immediately look for everything that's remotely similar. Because I don't want to sit there and wait for somebody to report them one by one. If I know that somebody somewhere did something wrong in the code base, I can expect somebody did something similar somewhere else.
Well, because a lot of times it's cut and paste. You see how someone else did it, and you cut it and put it in yours.
Even if they didn't cut and paste, they just have the same concept going in other places. So I don't know. I do spend time at work though, actually, just reading our code over and over again.
Yeah. Well, you use that as a sleep aid, maybe?
I enjoy it.
Someone's good.
How big is CPAN itself?
Before I left, the last number I had was 13 million lines of source.